Welcome to all. Myself Rajesh, Assistant Professor, Department of Food Technology, Excel Engineering College, Namakkal. In this video, we are going to discuss about reversed Carnot cycle and its operations. Reverse Carnot cycle does reverse the direction of heat and work interactions. The refrigerator and heat pump that operate on the reversed Carnot cycle, that's why it is called Carnot refrigeration or Carnot heat pump cycle. The reversed Carnot cycle is the most efficient refrigeration cycle operating between the two different temperature levels. One may be in higher temperature region, another one is in lower temperature regions. It sets the highest theoretical coefficient of performance. In this diagram shows the symmetric view of Carnot refrigeration cycles. Here we have four important components. First one is evaporator, compressor, condenser and turbines. In the first process 1 to 2, the refrigerator absorbs the heat from the low temperature source in isothermal process at constant temperature level, but here some amount of heat is absorbed by the refrigerant. In process 2 to 3 will occurs at compressor side. Here temperature also get increased from 2 to temperature T2 to T3. At this third one is process 3 to 4, a refrigerant reject the heat to higher temperature to the atmosphere through condensation process. That's why their region is condensation. Regions are, the device is called condenser. Here saturated vapor converted is a saturated liquid. Last one of the process is expansion devices done at expansion device in turbine. Here expansion done by adiabatically. At the same time temperature get decreases from T4 to T1. This also shows the what is the relation between temperature and isentropic in the view of TS diagram. Here cold medium, that is the refrigeration inner side, we called as cold medium or low temperature side. Here evaporation takes place by the refrigerant enter into the evaporator region. Here heat is absorbed from the refrigerator inside and it reject to the outside of the atmosphere through condenser side. Okay, in between these two processes we are going to carry out adiabatic compression and adiabatic expansion by means of compressor and turbines. Reversed Carnot cycle consists of four different processes: adiabatic compression, isothermal compression and adiabatic expansion and isothermal process. Isothermal expansion. In adiabatic compression, entropy may be kept at constant level. Isothermal process, both in isothermal compression and expansion, temperature kept in constant level. In this diagram shows the relationship between the pressure, volume and temperature and entropy relationship on reversed Carnot cycle. The process 1 to 2 shows the adiabatic compression of working fluid with the aid of external work. We are getting some external work from compressor or external electrical devices to start up the compression process, and the fluid refrigerant get into compressed in adiabatic manner. At the time we are going to keep the entropy constant, but temperature get increases from T1 level to T2 level. Process 2 to 3 is the isothermal compression. Here compression takes place in thermal view. When you are increase the pressure, temperature also get increases, but here we are going to keep the temperature is constant level, but we are going to increase the pressure. That's why in diagram pressure and volume, pressure get increases from 0.2 to 3. But here isothermally we are rejecting heat to environment. Process 3 to 4 is expansion process done at expansion device of turbine. Here the expansion process done in adiabatic manner. Here entropy also kept constant, but here temperature get decreases from 3 to 4. But here also phase changes occurs from vapor to liquid. Last one of the process is isothermal expansion. Here temperature may be kept constant, but we are observing some temperature from the cold medium, and that may be rejected to the hot medium through condensation process or adiabatic compression process. Reversal Carnot cycle, the result is a cycle that operates in the counter clockwise directions on TS diagram, which is called reversal Carnot cycle. The diagram shows the reversal Carnot cycle of DS diagram in the anti-clockwise direction or counter-clockwise direction of flow process. Here coefficient of performance in the refrigerator or refrigeration cycle calculated from heat absorbed by heat supplied. Otherwise we can calculate coefficient of performance in the refrigeration cooling effect by what is the input need to reject the heat. Here cooling effect, I mean what is the amount of heat absorbed from the refrigerant from the refrigerator regions, that may be QL or Q1. Okay, and in what is the input, work input means heat rejected to heat absorbed by the refrigerant. Those two differences is called work input. Here work input derived as Q1 minus Q2. Here Q1 is the heat absorbed by the refrigerant in the cold medium side, and Q2 is the heat rejected by the hot medium side. Here together we can calculate work input equal to heat rejected minus heat absorbed. COP commonly we can calculate heat absorbed by work supplied, or heat absorbed by heat rejected minus heat absorbed. Okay, finally we can get the formula like T2 divided by T1 minus T2. Okay, T2 is the nothing but heat absorbed or cooling effect at the cold medium side. T1 minus T2 is nothing but what is the work input needed to reject that much of heat, that is the work input. These two ratio called coefficient of performance. Practically the reversal Carnot cycle cannot be used for refrigeration purpose because adiabatic process requires very high speed operations, as well as the isothermal process requires very low speed operation. That is not so, practically that is impossible. Okay, thank you.